Measures of dispersion or variability or yung ating tinatawag na measures of variation. In summarizing a given set of data, sometimes the measures of central tendency, which is yung mean, mode, median natin, alone are not sufficient to give useful information. So they have to be supplemented by other measures of description, and such description is the measures of variability. So a measures of variability, by definition, indicates the extent to which values in a distributions are spread around the central tendency. So a measure of variation is a single value that is used to describe the spread of the distribution. So a measure of central tendency alone does not uniquely describe a distribution. Makikita lang natin sa ating measure of central tendency kung ano talaga yung value, pero hindi nyo kayang describe kung paano nag-distribute or paano nag-spread yung distribution. So how do we interpret and understand standard deviation? Dito na pumapasok, no, may SD na tayo dito. So we understand that the standard deviation measures the variation of values about the mean. Values close together will yield a small standard deviation. So sometimes yung sa other book, yung standard deviation is gumagawa sila ng SD. Yung iba naman S. Okay? Yung iba meron pang sigma. O depende kung ano yung ginamit na notation for that. Whereas, values spread farther apart will yield a larger standard deviation. So, sabi nga, kapag daw yung values close together, it will yield a small SD or standard deviation. Kapag naman daw yung values spread farther apart, it will yield a larger standard deviation. Because variation is such an important concept, and because the standard deviation is such an important tool in measuring variation. Kaya nga may variation, ibig sabihin nagbabari siya, di ba? So kung mas malapit daw yung variation ng values natin, small standard deviation yun. Kapag naman malayo, larger standard deviation yun. So ganun lang kadali mag-interpret. Okay? So there are ways of developing a sense for values of standard deviation. Then we have the concept. First is, variation refers to the amount that values vary among themselves. Next, values that are relatively close together have lower measures of variation. Nabanggit na natin kanina yan. And values that are spread farther apart have measures of variation that are larger. Ngayon, dyan napapasok yung ating tinatawag na range. Kasi we have the lower and the higher, di ba? The larger and the lower. So, meron tayong range. Yung range natin or yung ating R is the difference between the highest. Ito yung ating definition for that. So, this is the difference between the highest and the lowest. Okay? Kaya nga tinawag siya na range. Okay? Values in a distribution. It is a very rough measure of spread. And it provides useful but limited information since it depends only on the extreme values. Ngayon, ano naman yung tinatawag natin na sample variance or yung ating S-squared? Hindi po ito yung SD na standard deviation. Okay, yung ating sample variance, which is denoted by S-squared, is important measure of variation because it shows variation about the mean. So nandyan we have the tables. Under the measures of variability or their dispersion, we have two types, yung absolute at saka relative. Then under naman sa absolute, we have the range, variance, and standard deviation. While doon naman sa relative dispersion, we have the quantiles, coefficient of variation, we have the median, quartiles, deciles, and percentiles. Pero hindi na natin siya gaanong pagkakabalahan. Focus lang tayo dito sa SD at saka dito sa range and variance. So, yun. So, ano ba yung formula for variance? So, ito yun. So, for variance, we have two formula for that. Kasi we have population variance, and we have the sample variance. Okay? Bar na lang ilagay ko, no? Yan. For the formula of population variance, we have this one. Ito yung sinabi ko, sigma squared is equals to the summation of the quantity x minus mu, or yung ating mean is squared over n. So kapag population variance, yung n na ginagamit natin is malaki kasi nga, we are referring to the population or the number of the population. Wherein, sa sample variance naman, yung s squared natin dyan is equals to the summation of the quantity x minus bar x. Ito, alam na natin kung paano hanapin yan, over n minus 1. Okay, yung n natin dito is maliit kasi it signifies the sample size. And we also have the formula number 2, which is s squared is equals to n times the summation of x squared minus the quantity summation of x is squared. Okay? Over n times the quantity n minus 1. Again, yung ating n dyan is small letter n because it signifies the sample. Okay? Next is the standard deviation or yung ating SD. Yung ating namang standard deviation is the most important measure of variation. Kaya nga lagi tayong lagi nating naririnig or nakikita yung standard deviation na yan. It is the square root of variance. Okay? So square root lang pala siya ng variance. Meaning, yung formula natin dito sa ating population variance, papalitan lang natin. Okay? Kasi dito naka-squared yan sa ating sigma. So ilalagay natin dito square root. Okay? And dito naman sa ating ang taas, papalitan na natin to. Yung sample n saka variance. So ito na ay SD na or standard deviation na yan. And ito ulit, tanggalin natin yung mga square dyan. Ilipat natin sa kabila with the square root. So I hope na hindi kayo nalito. Ganun lang naman po kadali yung standard deviation. So ano yung remarks? So if there is a large amount of variation, then on average, the data values will be far from the mean. Hence, the SD or the standard deviation will be large. If there is only small amount of variation, then on average, the data values will be close to the mean. Hence, the standard deviation will be small. Okay? So halimbawa, mag-example tayo. Meron dyan example ng I-compare natin daw yung standard deviation. Example, Team A, yung heights nila ng 5 marathon players in inches is 65 inches. Nandyan naman, So yung mean nila dyan, syempre, 65 inches and yung S natin dyan is 0. Okay, so isulat lang natin yung kanilang problem. So therefore, ilagay muna natin yung formula for variance. So we have S squared is equals to the summation of the quantity x minus bar x squared over n minus 1. Kasi we are using yung variance muna, sample variance formula. Then, after that, meron pang isa, yung s squared is equals to yung population naman natin, yung n naman natin is yung sample. So that is n times the summation of x squared minus the quantity summation of x raised to 2 over n times n minus 1. Okay, so sabi dun sa problem, merong 5 marathon people, di ba? So yun yung height natin with the value of x na 65, 65, 65, 65, 65, and 65. Ngayon, ano ba yung nandyan? So di ba ang x natin is 65. Ano ba yung mean nung 65? 65 times 5 divided by 5 is 65. And yun yung ating squared kasi ito yun. Okay? So this would become x minus x bar squared is equals to 65 minus 65 squared or equals to 0. Lahat yan. Okay? Down to the bottom, 0, 0, 0 yan. Okay? And therefore, yung ating summation of x for this, ito ko na sa baba, summation of x is equals to 325, while yung ating summation of the quantity x minus bar x is equals to 0. Okay? Now, get the mean. O ito na nga, nakuha na natin yung mean, pero ipapakita ko pa rin. Yung x bar natin is equals to summation of x over n, which is equals to 325 over 5, and that is 65. Ginamit na natin yun kanina. After that, ilagay natin siya sa equation. S squared is equals to the summation of x minus x bar squared over n minus 1. Okay, ito, i-replace ko na to. So this would become 0 over 5 minus 1. Or this would equals to 0 over 4 or 0. Ngayon, ay di ba yan yung ating variance? Tapos kapag gumamit tayo ng standard deviation, mapapalitan lang itong s squared ng nandito na siya. Kung ano man yung value niya, nagiging squared na siya. Diba? So s is equals to square root of 0 is equals to 0. So ito yung ating variance. Ilagay ko ulit para makita nyo. Ito is variance. Ito naman ay SD. Okay, nagets na kasi nalipat na natin yung squared for that. Next. Ito namang sa kabila. Gamitin natin yung other formula. Ayan. So dito naman, we have ito pala yun, no? So, yung height natin, 65 pa rin. Yun yung ating x. So, lagay ko dyan, 65, 65, 65, 65, and 65. And then get the x squared. So, ano ba yung 65 squared? So, this is equals to 4,225. Down yan, pababa, ano? Compute nyo na lang. And then we get that the summation of x is also equals to 325, while the summation of x squared is equals to 21,125. Now, therefore, use the formula s squared is equals to the n, or yung ating sample size, times the summation of x squared minus the quantity summation of x raised to 2 over n times n minus 1. Okay? So, ito yung gagamitin natin, pero i-replace ko na yan to maximize the screen. So, this would become 5 times 21,125, yung nahanap natin kanina, minus 325 raised to 2 over yung ating 5 times 4. Kasi n minus 1 is 4. And we will get this s squared is equals to 0 over 20 or equals to 0. So again, yung s natin dyan is square root of 0. Yun yung ating variance. Pag ginawa nating standard deviation, that is equals to 0. Okay na. So, ganun po siya, mag-compare ng standard deviation. Meron pang another example. So, yung team B naman, no? Yung team B kasi, di ba, yung team A, magkaka-height sila. Okay? So, dito, gawin nga natin to para makita natin yung pagkakaiba nila. So, yung example B, magkakaiba-iba yung height nila. Okay? So, ang height dyan is 62 inches, 67, 66. O, igawa ko na lang siya sa pababa, no? Dito ko na lang. Unahin muna natin yung formula kanina. So, s squared is equals to summation of the quantity x minus bar x raised to 2 over n minus 1. Whereas yung isa naman is s squared is equals to n times the quantity x summation of n times the summation of x squared minus the quantity summation of x raised to 2 over n times n minus 1. Okay, so ano ba yung ating mga heights? So yun pa rin yung ating x value. We have 62, 67, 66, 70, and 60. Okay? So, ang ating summation of x is equals to 325 pa rin. Divide natin siya sa 5 para makuha natin yung bar x or yung mean. This is also equals to 65. Pero dito sa ating x minus bar x squared ay magkakaiba na. Okay? Kasi hindi na siya para-pareho, hindi na siya katulad nung kanina. So this would equals to 62 minus 65 squared. So that is equals to negative 3 or negative 3 squared, that is 9. Okay? Dito naman, 67 minus 65 or that is 2 raised to 2 is 4. Dito naman, 66 minus 65, that is 1 raised to 2 is 1. Dito naman, 70 minus 65 is 5 raised to 2 is 25. Dito naman, 60 minus 65 is negative 5 raised to 2 is 25. So we have the summation of the quantity x minus bar x is equals to 64. So nagkaiba na siya, hindi na siya katulad nung kanina. Then after that, use the equation natin, yung s squared natin. Pero at this time, ang gagawin ko na siyang, isasubstitute ko na yung ating mga values. So s squared is equals to 64 over 5 minus 1 or 4. That is 64 over 4 or equals to 16. Ay, yung atin namang, ito variance yan, ano? So ating standard deviation is the square root of 16 or that is equals to 4. Okay, now let us come to the other equation. So ito. So we also have the height, yung ating x value, 62, 67, 66, 70, and 60. This time, gagawin natin siya ulit na x squared, di ba? So 62 squared is equals to 3,844. 67 squared is 4,489. 66 squared is 4,356. 70 squared is 4,900. And 60 squared is 3,600. And yung ating summation of x ulit is 325. While yung ating summation of x squared is equals to 21,189. So at this time, use the formula. Pero ang gagawin ko ulit is substitute ko na. So this would become 5 times 21,189 minus the quantity 325 squared over 5 times 4. Simplifying further, this would give us 320 over 20. Yan yung ating variance. So this should equals to 16 and convert that into standard deviation, which is S is equals to, or SD is equals to square root of 16. So this would give us the value of 4. Same lang siya. So ganun po. So obtaining the sample variance and standard deviation from a simple frequency, yan, meron pang isa dyan, pero ito ay manageable naman yan. So I hope na nakuha nyo kung paano or ano yung principle ng measures of variation. So dito, wala akong nilagay na activity pero siguro sa ating quiz, kukuha ako dito sa measures of variation naman. Simple lang, no? Mga solving for sample standard deviation and sample variance. Okay? So when the various measures of variability are used, so first, pag range, this is the least reliable of the measure and is used only when one is in hurry to get a measure of variability. Kasi ano lang, kukunin mo lang yung difference niya eh. Diba? So ito yung pinaka-least reliable of the measures. While yung standard deviation naman at saka yung variance is however used whenever a distribution approximates a normal distribution. So alam nyo naman kapag normal distribution, di ba, meron tayong ano dyan, yung curve. Di ba? Pag normal, parang ganyan yan. Okay? O, di ba? So, meron akong niligay dyan na na tawag dyan, picture or illustration. So, it is the basis for much of the statistics as the most reliable measure of variability. It is used when interval and ratio data use standard deviation or variance when two means are equal. Okay? So, alam niyo na kung ano pagkakaiba ng variance at saka its standard deviation, di ba? Yung variance, naka-squared, Yung standard deviation, yung squared, convert natin siya into square root. Ngayon, meron ako ipapakita, nandiyan naman yan sa sa lesson natin. Pero ito yun, ito yung normal distribution, kunyari. Yan. Okay? So dito sa normal distribution na yan, we cut this into two parts. Okay? Sa left and right. Okay? Tapos ito yung ating bar x. Ngayon, yung ating first standard deviation or one standard deviation na nakalagay. Ito sample lang naman kasi ito, no? Yung mga value dyan is sample lang para lang maipakita natin kung ano yung relevance nitong variation na yan. So we have this one. Ayan. So ito yung measure na one standard deviation. So meaning, bar x minus s. At dito naman, bar x plus x. S. Okay? The next is bar x plus 2s. And dito sa last is bar x plus 3s. Dito, same lang din, bar x minus 2s and bar x minus 3s. Yan. Okay? So assume that yung nandito is 34%. So, syempre, kung ano yung nandyan, ito din yung nandyan kasi normal nga. Okay? So meaning, napalitan ko na, meron pa ditong given na 13.5%. Also 13.5%. And this is 24%. Tapos, meron pa dito na 0.1%. Mali. Linawin natin to. No? Nawala tuloy. Ayan. Dito ay 0.1%. Dito, 24%. Ayan. And dito naman ay 0.1%. Okay? Ngayon, paano ba natin to interpret? So within one standard deviation, di ba ito within one standard deviation yan? Okay? So dito, times mo lang yan, so that is 68%. Within that first standard deviation, 68% yung ating measures of variation. Within naman, dito sa ating second standard deviation, i-add mo lang yung 13.5 at saka 13.5 and this would result as to 95%. Ito naman yung measures of variation within that second standard deviation. And of course, kunin mo pa rin yung nandun sa ito 2.4 yan huwag kayong malito, no? Maliit na nga eh. So, kapag naman nandito na tayo sa third, ayan, pwede pa bang ibaba? Hindi na. So, dito na lang sa taas. Okay? So, ito naman yung third. Ilagay ko na lang sa taas, Yung third standard deviation naman, it means that yung mean natin is from bar x minus 3s to x bar plus 3s. Yan yung ating range, di ba? Ang laki na. And if you add that measure of variation, this will give us 99.7%. Hindi pa siya full 100% kasi we also have 0.1 dyan sa gilid na pwede mong i-add. So majority within one standard deviation, for most frequency distribution, a majority as often as 68%. Ito daw yung majority. Kaya nga ito yung ginawa natin na illustration. So of all observations are within one standard deviation on either side of the mean. So minority naman, minority deviate outside two standard deviation for most frequency distribution. A small minority often as small as 5%. So of all distribution deviate more than two standard deviation on either side or of the mean. And the last one is usual or normal within two standard deviation is 95%. Kaya nga meron tayong level of significance na 95%, di ba? So majority of the distribution, yun yung x bar plus 1s. Okay? Yun yung natin within one standard deviation. Ano pa ba? Okay, yung skewness naman, nandyan pa rin naman yung skewness, no? Nakalagay dyan, skewed to the left, then symmetric. Ito symmetric naman yan, And then yung median naman is skewed to the right. Yun ang ibig sabihin. Positively skewed siya kapag skewed to the right and mas marami ang mas marami ang ang tawag diyan, mas marami ang mode. Ang mode niya is nasa right ng median. Okay? Kapag skewed to the left naman, yung mode is nasa left ng median. And ayan. So, dito sa illustration natin, saan natin makikita yung mode dyan? So, yung mode dyan ay nasa gitna kasi nandyan yung may pinakamaraming given value, di ba? So, halimbawa, nandito yung median, nandito naman yung mean. Okay, kasi nga, mean, yun ang tawag natin sa mean. Or, loop-sided to the right, loop-sided to the left, and data is not loop-sided. Ayun. So, yung interval natin dyan, when the interval is greater than or equals to 1, data can be considered to be significantly skewed to the right, while if the interval is less than or equal to -1, the data are considered to be significantly skewed to the left. Then meron din example, kindly use the second coefficient of skewness. Pero pwede nyo naman itong, tingnan nyo na lang kung paano nangyari yan. So we have the actor and actresses. Yan, kinuha lang naman yung skewness dyan. Tapos, meron pa yung level of acceptability. So ito ginagamit ito kapag meron tayong mga research na merong mga about sa level of acceptability. No? Nakukuha natin yung mean. And of course, the standard deviation. Yan. So I hope you got something in this video. Thank you for listening.